Modern enterprise IT architecture locks down user environments with strict, uncompromising perimeters. Users attempting to deploy external AI tools typically hit three hard roadblocks. First, unauthorized browser extensions are blocked. Second, external API requests are denied. Third, specific execution environments are prohibited. These are not flaws in the system. This perimeter is built specifically to prevent third-party servers from accessing and processing internal corporate data. Standard AI copilots rely on exactly these traditional pathways to function. When the pathways are severed, the tools stop working. The core obstacle for enterprise users is not the intelligence of the AI model. It is the rigid architecture of the local security perimeter. But an entirely different approach has now emerged to safely circumvent these defenses. Genspark 4.0 utilizes a new system called the Claw. Instead of forcing its way through local restrictions, this system abandons local execution and API handshakes. It arcs entirely over the local firewall. This bypass is achieved through two distinct mechanisms: isolated cloud computing and desktop vision. To understand how this operates, we must systematically deconstruct exactly how it neutralizes local network filters, API blocks, and execution bans. Doing so requires shifting our understanding of software integration, moving away from internal code requests and toward external visual simulation. Corporate networks tightly control the data packets moving from company-owned hardware to external servers. To avoid this filter, the execution environment is extracted. Genspark provisions a cloud virtual machine, a dedicated computer hosted entirely on the internet. Your local machine is demoted to a simple terminal. You use the pre-approved Edge browser solely to view this cloud machine through a secure tunnel. Heavy analytical tasks happen exclusively in the isolated cloud space. The local corporate hardware carries zero processing load. When the AI needs to interact with web apps like Outlook or Teams, it queries the internet directly from that cloud machine, entirely circumventing your local corporate network infrastructure. Older AI deployments require the local machine to act as a middleman, pulling data down to the desktop just to send it back up to an external server. Standard corporate firewalls are designed to monitor traffic originating from the local endpoint. They do not monitor the independent actions of a remote virtual machine. Because the local PC is technically doing nothing more than displaying a web page, local security agents see no malicious executables or unauthorized extensions to block. Furthermore, this cloud space remains securely siloed for each individual user, maintaining strict data isolation. By physically removing the execution environment from the local device, endpoint hardware constraints and local network filters are rendered irrelevant. The second barrier is the enterprise ban on external applications reading database backends. Normally, software pulls structured data directly from an application using an API. When security severs that connection, the request shatters against the firewall. Traditional AI copilots are blind without that structured code data. They immediately fail. Genspark's Claw bypasses this by abandoning APIs. It uses desktop vision. This diagram shows the mechanism at work. The agent scans the raw pixel output of the screen, reading the visual layout exactly as a human user would. Using optical character recognition and layout analysis, the AI parses the exact context of the active Teams or Outlook window and extracts the relevant text. Once it understands the layout of the screen, the agent must execute commands without an API to carry them. It generates virtual keystrokes and mouse clicks, mapping them directly to the coordinate geometry. To the host application, these generated pixels and coordinates are indistinguishable from physical human interaction. No direct database connection is ever established. The API security perimeter is bypassed entirely. By shifting from code-to-code requests to pixel-to-pixel interaction, the AI effectively disguises itself as a human operator, neutralizing traditional application blockades. The final technical hurdle involves hard-coded IT policies that ban specific software environments, most commonly the prohibition of Google Chrome. Many legacy AI tools are crippled in the enterprise because they were built exclusively as Chrome extensions. Genspark 4.0 bypasses this restriction by decoupling the AI from any single browser dependency. It can run as an independent desktop application or operate as a virtualized OS directly within Microsoft Edge. Because Edge is almost universally whitelisted in Microsoft-dominated enterprise environments, the agent passes through pre-approved channels. This environment agnosticism renders IT policies that target specific consumer browsers ineffective. We've bypassed local hardware filters, bypassed API restrictions, and bypassed browser bans. From a purely technical standpoint, the wall preventing external AI from operating inside lockdown corporate networks is dismantled. Cautionary: technical capability does not equal corporate permission. Executing this bypass introduces severe compliance risks. The first major risk triggers data loss prevention, or DLP systems, the final enterprise safety net. While the AI looks human, sending an automated stream of parsed text to an external VM will likely be flagged by security software as unauthorized data exfiltration. The second risk is shadow IT. Logging into internal corporate accounts from an unverified external cloud virtual machine directly violates standard security protocols. The desktop agent is an effective technical lockpick, but reckless deployment will trigger a rapid InfoSec compliance failure. To deploy Vision agents safely, the system must be purposefully throttled back from full autonomy. The recommended deployment model restricts the agent to an internal analytical tool, housed securely within the permitted Edge sidebar. By limiting the Claw agent to simply reading the screen and organizing information locally, it functions as a passive assistant rather than an active driver. This read-only constraint keeps the user strictly within the boundaries of acceptable tool usage policies. It eliminates the manual labor of copy-pasting data between environments without generating the rapid outbound traffic that triggers automated DLP or API alarms. Final, definitive tone. Deploying these agents effectively demands a careful balance between automated screen interaction and the strict oversight of enterprise security policy.